This is a stats question from one of the CCEA A2 Applied Maths practice papers. This one's from September 2021 and it's question 7. It's a question on normal distribution. So let's take a wee look then at what's being asked. It says the length of leaves on a large tree are normally distributed with a mean mu standard deviation of 6. 18% of the leaves have lengths greater than 155.5. Find the value of mu. Again, a couple of ways to tackle this one, but we're going to get our, I guess we try and find where we are in terms of our bell curve. So we're trying to find our mean, which is going to be mu here, and then we know then that 18% is going to be there, so that's going to be 0.18, and that's at my 155.5 mark. So what I'm going to do is I'm going to take that away from 1 and get 0.82. So I'm going to find an area then of 0.82 and work from there. So I'm trying to find my value of z, which equals 0.82. So my z value for that, and again there's a few different ways of doing this. So 0.82, there's 0.8186 and there's 0.82. So let's bring it down so we can read stuff. So it's going to be 0.91, and then we want to add 14 to this to get 0.82. So if I go across to here, we're between 13 and 15. For 13 we add 5, so I'm going to go halfway in between. So it's 0.9155 is the value I'm going to take. 9155. So my z value is that. Using my then formula, so z is x minus mu all over sigma, 0.9155. My x value here is 155.5. Take away mu, and then sigma in this case then is going to be, sigma then is 6. So multiplying through, I'm going to get my calculator. 6 times 0.9155 times by 6 gives me 5.493. 155.5 minus mu, so I take my mu over to the other side, then 155.5 minus that, so and I end up then with 150.01. So my answer then is 150. That then is the 3 significant figures, and that value then is obviously in millimeters. Part 2 then, find the probability that a randomly selected leaf has length less than 160. So we now know, I guess, where we are. We have our value of x, as it really should be a capital X, right? Normal distribution, 150, and then 6 squared. So 150 obviously being my mean, and 6 squared being my variance. And we're trying to work out in my area then the probability less than 160. We know this is 150 here, and we know this is 160, and I'm trying to find then this area here. So we can do it a couple of different ways without using the calculator then. Probability of x being less than 160 is equal to the probability of my z value then being less, so it's x minus mu, so it's obviously 160, take away 150 all over 6. So that gives me a z value then of kind of 10 over 6, so 1.6645, I believe. Let me just check on the other calculator actually. Yeah, sorry, it's just 1.6 recurring. I've stolen it from another thing where they have a slightly more accurate value of that. So we're 1.66, and then if we look up our probability table, so it's 1.664. So there's 1.6. 1.66 is 0.9515, and then if we're adding then a 4, so it's not, sorry, let me just check what it is. 1.666 effectively. Let's go. So 1.66, 0.515, and then adding 6 to it, then we'll add 6, so it's 0.9521. So my probability then is 0.952 to 3 significant figures. Ignore that wee bit there, it's kind of a 5 or 3 values that we have. The other way of doing it is if we go hit number 7 on this calculator here, and I want 2. My lower one is going to be 0. My upper one, I already have it in here, is 160. My standard deviation is 6, and my mean is 150. And we hit equals, and we get 0.952. Hopefully you can see that there okay, to give us our answer then for that bit. Okay, part 3 then. Given that a leaf selected at random has a length less than 160 in length, find the probability the leaf has a length between 155.5 and 160. There's a wee bit of conditional probability in there actually, but we'll worry about it then whenever we get to it. Now we have these values already worked out kind of in the previous part, so let's just work our way through. So again, we're normal distribution, and then working with 150. I should maybe be a bit more accurate than that, but that's what we're going with. And we have that, and we're trying to find about the probability between 155.5 less than or equal to x less than 160. So that's obviously the probability that x is less than 160. Take away the probability that x is less than 155.5. So for the 161, we had 0.952. For the 155.5 one, that was our part 1. I don't know if you remember, it says it was 82%, so that then was 0.82. So if we subtract those, we get 0.132. And that's our answer then to 3 significant figures. Now we're not quite there, so it then says the probability. Sorry, the other way we can do this obviously is if we kind of if I go menu and 7 and 2 again, and my lower 155.5 again, I hope you can see that, equals 160, and there's your 0.132. So that'll work out kind of straight out for you, another way of kind of sort of saving your working that out. And we have that, but it says then, given that the leaf is less than 160, find the probability the leaf is between 155 and 160. So the probability required is going to be 0.132 divided by 0.952. 0.132 divided by 0.952, and we get 0.139, which is our final answer.